Hi there. So today I'm going to talk about real-time graph analytics. First, a little bit about myself. So my name is Katarina. I'm a developer relations engineer at Memgraph. I was born at the Croatian coast in a small town of Šibenik. I did my master's in computer science and mathematics from the Faculty of Science in Zagreb. And as everyone, I love to travel, cook, and eat tasty food. You can check out my Instagram because I only have food there, so feel free to follow. So first, let me tell you a bit about graph analytics, and then we are going to dive a bit deeper into the topic. So what are graph analytics? Graph analytics are also called network analysis, and they generate insights hidden in the relationships of the network structure. Some common algorithms are clustering and community detection, connected components, page rank, shortest path, BFS, and DFS. Maybe you heard about some of them, maybe not, but I'm going to show you an example later on what they are. When even to use graph analytics? So there are many of companies that are currently using graph analytics, and they found really valuable insights from their data using graph analytics. For example, we have Google, who invented PageRank algorithm for the ranking of search results. We have Facebook with different kind of community detection algorithms to determine different kind of communities in the social network. We have different kinds of recommendation system with graph algorithms, and for example, Amazon uses one of them. Pinterest uses random walks and graph machine learning, and also Uber Eats uses graph machine learning. There are many companies who found graph algorithms really valuable for their use cases. So what are maybe the most popular use cases? As I mentioned, social networks, because you have some kind of network that is highly connected, such as this one. You have a user that is friend with user, and so on. And with the help of graph algorithms such as community detection, you can determine different kind of communities in these kind of networks. You can also generate link predictions to give some recommendations, for example, who can be your next friend in this social network, and so on. This is a fun photo that shows, this is a black background, and actually the highlighted things are nodes and relationships between them, and actually these are all users of Facebooks and their friendships between them. So this actually shows that this kind of network is highly connected because it actually creates a map of the world. So the whole world is connected with this social network. Another good use case would be recommendation engines. For example, here we have a drawing of some kind of movie data set, let's say. So we have movies that are of some genre, and we have users that rated different movies and so on. And what you can do here is determine different kinds of, you can determine similar users based on the same movies they watch, like maybe they rated it similarly and then have similar taste, and then you can, based on that, recommend another movie. So this is just a simple example, but it can be used in movie recommendations, music recommendations, product recommendations, and so on. Then we have some kind of more business example. So it's supply chain management. Here you can determine if something goes wrong. For example, if raw supplier doesn't deliver something to the supplier, then what will happen? You can do some kind of, you can find a weak link in this network. You can do different kinds of business risk analysis, and in that way optimize your supply chain. Another really popular example is fraud detection. You can have different kinds of fraud detections, let's say insurance fraud detection, and also here we have a card fraud detection. What this does, you can run different kind of graph algorithms on this kind of network, and with the graph, you can, for example, with community detection, you can determine fraudsters that are maybe working together. With different kinds of graph traversals, you can find where the fraud originally came from, and something similar to that. So you can play with different set of algorithms and maybe find more value from your data. But this kind of data is, you can You can find it like it's static data, but you can also maybe explore some kind of real-time data. This may be useful, especially in examples such as card fraud detection. I mean, you want the answers as soon as possible, and you want to determine something that will maybe make your business more successful, and it makes sense to have those results as fast as possible, especially if something like fraud happened, so that you can stop it on time and so on. So now I'm going to tell you a bit more about graph stream processing. With the help of graph stream processing, you can analyze your data in real time instead of in batches. So what this actually does, you have some kind of stream of data that is called input data, and this data goes into the stream processing engine. Once it's in the stream processing engine, you can run different kind of graph algorithms inside, and then the results are going to the output stream or to the different kind of analytics tool. So with the output stream, you can also then send it again wherever you want. But the most important part, I would say, is the stream processing engine that allows you to run different kind of algorithms. Before I head over to the graph data model, I would like to mention that you can run like different set of traditional static graph algorithms such as PageRank, community detection, between centrality, and so on. But what makes maybe more sense is to run dynamic algorithms. So what happens is if you, for example, run dynamic page algorithm on the new data, whenever new data comes, so whenever something new is created in the database, then you, for example, calculate new values of PageRank locally around some node, and then these approximate values get propagated through the whole graph. And then you actually get the results much faster. You don't have to wait for it to load, like to be run on the whole graph that can be like, let's say, hundreds of millions of nodes and so on, but rather you get the results back pretty fast. So I think that this kind of graph stream processing makes sense if you have dynamic graph algorithms. So I'm talking about graphs a lot, but I still haven't actually told what they are. So this can be only a visualization of the data that you have in some kind of relational database, but what we like to talk about today is a graph data model and graph databases. So what they actually are. So what are graphs first? Graph is a network structure that consists of set of nodes and set of relationships. You may notice vertices, edges, points, links, like many different naming conventions, but let's say we try to use nodes and relationships. Sorry if I get messed up here. So yeah, we have nodes, relationships, and properties. These properties are actually associated values belonging to either nodes or relationships. So when you look to the photo to the right, you can notice some kind of graph. This is actually called labeled property graph model because of the labels on each node and because of the properties on nodes and relationships. So what we have here, we have like a node that is labeled with person, and we have another node that has two labels called city and location. So this means that each node can have not only one, but more than one labels. We also have some kind of labels on the relationships. These are actually called types. So we have a relationship of type married to, and we have a relationship of type lives in. Each of these relationships and nodes have also properties. For example, relationship of type married to has property wedding date, and a node that is labeled with person has two properties, name and date of birth. So this is just a simple example how graph data model can look like, but I'm going to show you on the example later on, like a true example where you can see the true value of this kind of model. So you may be wondering, if you are using relational databases, why would you even need a graph database? So this is a really good question, and actually it's not like yeah, you should all use graph databases, but it's rather like, what is your exact use case? So I can give you a couple of differences, and maybe when it does make sense to use graph databases, and then based upon that you can think about your data and your data model and whether that makes sense. So relational databases have a certain schema that you have to follow, while in graph databases there is no schema, they are schemaless. So you're a bit more flexible with your data. For example, you can have nodes that are labeled the same, but they have a different set of properties, and so on. Also, the main difference is that your data is already connected in the beginning in the graph databases. So you have a node, and this node holds the information to which nodes it is connected to. While in the relational databases, you have tables, and they are not connected. And if you want to run some query on that data, and that you should connect different tables, then you have to do it all in one query. You have to join the tables in order to connect them. And here in graph databases, it's already connected. So when does it make sense to even use graph databases? So if your data is highly connected. So in relational databases, to query that kind of data, you would have to do a lot of joins, and then things got really complicated. While in graph databases, it's quite simple. I mean, I'm going to show you a simple example of that, but yeah, I think you should see as more example as you see, the more intuitive it gets when to use graph databases. So the most widely adopted language used for communication with graph databases is Cypher. This is very similar to SQL. The biggest difference is that it is pretty intuitive because it uses different set of paths that you actually are matching with the database, with something that is in the database, and then your queries get a little bit shorter. But what it has clauses such as match, delete, set, return. It has functions such as round, to string, cosinus, and so on. And also what you can do, for example, in Memgraph, you can create custom procedures that can be written in Python, C, C++, and Rust. And in that way, if there is something that you don't have in Cypher and you want to use it, you can just write it on by yourself. So what is the difference between these two languages? I'm not saying that SQL is bad. I mean, it's not, but just if you have a graph use case, then maybe graph database is where you should store your data because it would be much easier to query. For example, here we have some kind of recommendation. So on the left side with Cypher, what we are actually doing, we have match. This means select, and we are trying to find a node that is a customer of ID customer 1 that has bought some product. So this bought is actually type of relationship, and the product is label of some other node. And we are trying to find a customer who also bought that product and which other product did that other customer bought. So this is something that we would like to recommend to the first customer. But we don't want to recommend to the first customer things that customer already bought. This is why we have this where not clause. And in the end, give us a recommendation, but we want the one that makes most sense. This is why we have this order by descending. So actually the best recommendation goes on top. On the right side, I'm not going to explain this query, but actually it just proves that you have, in order to do that, you have to get the data from a bunch of tables, do the joins. It's not necessarily a bad thing, but it's just from user point of view, maybe it's a bit easier to do something that is more intuitive. Okay, now I talked a bit about graph analytics in general. I talked a bit about graph databases in general, and now I'm going to tell you a bit more about what we do in Memgraph. So what is actually Memgraph? Memgraph is a platform for graph computation and streaming data, and it is powered by in-memory graph database. This graph database is implemented in C++. So we use Memgraph. When we say platform, we say that we actually use it not only to store graph data in memory, but also to run graph analytics and to analyze streaming data. Therefore, we have a different set of static, traditional graph algorithms, and also dynamic ones. So when I say that we have it, this means that actually we have an open source repository of graph algorithms. So this kind of algorithms is used so that you can tackle the most interesting and challenging graph analytics problems. And we call these algorithms, that is, these procedures, we call them query modules. This is kind of a set of user-defined procedures. And as I said, these are dynamic and static graph algorithms that are runnable inside Memgraph. You can write by yourself also these kind of algorithms and contribute to the MAGE repository, but also we have a couple of our own algorithms. This is like a list of couple of our algorithms. Maybe these kind of algorithms are familiar to you. You can also see in which language these are written. We have like this between a centrality and then between a centrality online. So this is like a static and dynamic version. We also have a QGraph algorithm, query module that is. So yeah, there is a bunch of stuff here. We also have NetworkX integration, but you can head over to our website and check it all out, maybe try it out. Another thing that I would like to mention, because I'm going to use it in the demo when explaining to you, this is like our most popular client. It's our Python client. It's called GQL Alchemy, and it's again fully open source Python library. So it is an object graph mapper. This means that it is a link between graph database objects and Python objects. So you don't have to worry if you don't use Python. You can use whichever client that we have. I just mentioned this one because the demo is built with Python in the backend, so I wanted to share this info with you. So what I use from here, I used OGM capabilities, so I can define classes for nodes and relationships, have some kind of schema validation if I want. I also use Query Builder because it helps if you are not familiar with Cypher query language, then you can just simply run your Python code. It also has on-disk storage, different kinds of importers, NetworkX integration, and so on. So yeah, you can also check it out on our GitHub, but let me head over to the demo. So what I did in demo, this is a Twitter demo that's going to showcase graph-based stream processing. So we had a fun game last Christmas, and we used #Christmas on Twitter. We scraped a bunch of data, and we wanted to run dynamic page algorithm and dynamic community detection algorithm on that data. So we wanted to figure out like who is the most Christmassy person on Twitter and which accounts belong to the same community. So the data set, like the graph data model that was used, is just a simple graph data model. It's nothing complicated. It's just a user. So nodes that are labeled with user, they have property called username, and relationships are of type retweeted between users. So user retweeted user, and so on. So this is how the whole, like we created the whole web application, and this is kind of the architecture of that application. So we use Twitter as a data source. This data is being sent to Kafka, and then from Kafka it's being sent to Memgraph. Once the data is being processed, like Memgraph is here like a stream processing engine. Once the data is being processed, the results are being sent back to Kafka topic, because we have, like, first the data can be consumed in Memgraph because we have Kafka consumer inside Memgraph. We have a Kafka, Red Panda, and Pulsar consumer inside Memgraph. Once the data is inside Memgraph, then the trigger, we have a database trigger that tells us to run different kind of algorithm. In this case, we run dynamic page rank and dynamic community detection algorithm. And then once the results are done, we have a Kafka producer that sends data back to Kafka topic. So then we have a backend server built in Python. It's a Flask server. And this server actually waits for Kafka messages from that topic. Once the data is in, we send that data, the results, to the front end via WebSocket, and front end client is built with React and D3.js library for visualization. You can also notice the direct connection between Memgraph and Flask. This is actually just the query data, whatever we need. So I know it may seem like a lot for just one simple web application, but this was really fun example to do to showcase what would the architecture for stream processing look like, and also to showcase that we have a different set of consumers inside Memgraph and what happens when we set up dynamic algorithm to be run. Okay, so what are we actually doing? First, in order to achieve this whole graph stream processing inside Memgraph, we need to create a transformation module. What this transformation module does, it actually translates all the messages from Kafka topic to Cypher queries. So whenever something new comes, like in a form of JSON or whatever, and what we actually get is a new tweet, new retweet, then we tell Memgraph to create a node like user 1, user 2, and create a relationship between them of type retweeted. So you can see here that actually parameters are from Kafka topic, and we are actually getting from the dictionary called tweetdict, and from that we get a property username which can be used in a Cypher query. So this is actually, transformation module is actually like a way for Memgraph to translate everything to Memgraph Cypher queries. Next, we have to set everything up for dynamic PageRank algorithm. So we are just calling a procedure to set everything up. We have different set of parameters depending on what's our use case. And here we want to create a trigger, and this trigger tells dynamic PageRank algorithm that whenever something new is created, it needs to set a new rank. After that, we call this procedure called update rank from the publisher query module. What this does, it sends just the new information about the new page rank to Kafka topic. It produces messages to Kafka topic that are being read in the Flask backend server. And another thing that we have to do, we have to create and start stream inside Memgraph. This tells Memgraph, okay, create this Kafka stream and read from certain topic and use certain transformation module. So that's it. Like we tell it to use the transformation module that I mentioned before and to read from topics called retweets. And we create and start stream. These procedures that you can see here and this class called Memgraph Kafka stream. This is all in Python, and this is all a part of from GQL Alchemy. In the end, we already created some trigger. This was used for dynamic algorithms, but this trigger is just a simple trigger for creation of objects. So whenever something new is inside database and we want to see it on the front end, so not only when the value of PageRank is updated, but also when something new is created in the database, we created another simple Memgraph trigger. This is like not related to algorithms, just a simple trigger that says, okay, whenever something new is created, then run create procedure from publisher query module, and it sends data about created objects to Kafka topic that is again being read from the backend. Okay, so this is how it's going to look in the end, but let me show you. Let me first fire up the app and show you how it actually works. So first, I'm going to run the backend service. I'm going to run the Kafka, Zookeeper, Memgraph Mage, and whole backend application with this script. And once this is run, I can also run the front-end service. And once I open up the front-end application on localhost 3000, actually then the backend will be triggered to run new messages, to send new messages to Kafka topic. Let me now fire up the front-end application because backend is up. Actually what we did, we created a small mock of stream because we scraped data before since it was Christmas and now it's not Christmas. So we scraped the data before and we are just producing it with Kafka. Okay, I think everything is up. I'm going to fire it up. And let's see what's happening. So we can see just a sec. These are just small messages that new data is being sent. And let's see. Okay, something is happening here. So what's happening whenever something new is here, whenever something new is created, then it's being drawn on the front-end side. But also you can notice that the size of the nodes is changing. So let me just wait a bit. So yeah, these ones are getting smaller and smaller. So what I actually created is whenever something new whenever PageRank is updated, I'm changing the radius of these circles based on the PageRank values. So yeah, so this is why we had those triggers. Those triggers said, okay, send me the new information about the new change, about the new update of PageRank to the front end and to the back end, and then to the front end through the WebSocket, and that's how I can have these cool visualizations. Okay, down here we have community detection. Maybe you'll notice some colors changing. This is not size is changing, just colors. So what happens here is we have this similar setup to PageRank. I haven't mentioned it before, but actually we have a pretty same setup, it's called community detection, not PageRank. But what it does, this algorithm determines different kind of communities from these Twitter users, and whenever some node changes its community, it changes also colors. So yeah, this is just this was a fun project to work on because I learned a lot about D3.js, I learned about graph stream processing, and we managed to create these cool visualizations to be able to show you. Hopefully you like it. Yeah, so let's check this out. Okay. This one is pretty popular. World Music Award. I guess everything spins around this node. Yeah, so actually that's it. That's pretty much it. Let me stop the demo and do the outro. I can do it here. Okay. So we saw this. I like these visualizations here. It's pretty calming to watch it. Okay, so if you want to play by yourself with the Twitter dataset, we have something set up on our playground. This playground, Memgraph Playground, is actually a pretty good resource if you want to start learning about graphs, if you want to start learning about Cypher. There you can also learn how to run different algorithms, and also this embedded image here is actually from our Memgraph Lab. That is our visual user interface, which you can also download. So this is pretty cool and visual. You can also embed it somewhere else. You can share it with other people. So there are many interesting data sets there, like Game of Thrones, Twitter, and so on. So feel free to play with it. Okay, thank you very much for your attention. Hopefully you like the presentation, and if you have any questions, feel free to ping me. If you like what we do, just throw us a star on GitHub. We are open source, and all of our tooling around Memgraph is also open source, so feel free to throw us a star. It means a lot. If you want to check out this demo, everything is, again, open source. You can check it out on GitHub. And yeah, as I said, feel free to contact me if you need anything. I'm also available on Twitter. And if you want to join our community, you decide to use Memgraph, or you have some use case, not sure whether it's graph use case, have a graph use case, just join our Discord server. And yeah, we can talk there a bit. Thank you so much for your attention, and bye.